Today we are going to practice interpreting graphs of proportional relationships. We've already learned how to create graphs and determine if they form proportional relationships or not. Today we're going to talk about taking a graph that's pre-made and interpreting information from that graph. Before we get started, I want us to remember two things. The first one is that two quantities are proportional if, when they are graphed, they go through the origin and form a straight line. I also want us to remember, and we'll go through this and review this as we go through the lesson today, but the constant of proportionality, otherwise known as the unit rate, is the constant value showing increase or decrease of two proportional quantities. So let's start with our first example. It says interpreting points and constant of proportionality on the graph. Okay, so this is a graph showing the distance traveled by the Curiosity Mars rover. Okay, so that's a space rover that can go on Mars. First of all, is the distance traveled proportional to the time traveled? So down here we have time and distance, and we want to know if these two are proportional to each other. So we look at the line that they create. Is this line proportional? How do you know? Well, it is proportional because, first of all, it is straight. There are no bends or curves in this line, but also it intersects the origin. So when it has moved 0 seconds, it moves a 0 distance. It has moved 0 inches. Intersects origin, which is 0, 0. So that's the first piece. The next piece is interpreting the separate points on the graph. So we want to take a look at the points here that are found on the graph and determine what they mean. So we will use sentences to describe this point. So for example, we are comparing X and Y. X is seconds and Y is inches. Here we have 0, 0. So we would say in 0 seconds, the rover travels 0 inches. Okay, so according to this data, in 0 seconds, the rover travels 0 inches. Now, if we go to the next point, 1, 1.5, that tells us the X is seconds. So in 1 second, the rover travels 1.5 inches. Why don't you try letter C? How would I write a sentence interpreting this point? I would say in my X is 3, in 3 seconds, the rover travels 4.5 inches. Okay, so when we interpret our points, this is what we mean. We want to take a point and put it into words. What is it showing us? Okay. The next piece, the third piece, is finding the unit rate or the constant of proportionality. The unit rate in a proportional graph can be identified using this point. So we know that a unit rate always has a denominator of 0, of 1. I am sorry. So here we know that our X is our first one and our Y is our second one in our ordered pair. We also know that when we're talking about this, that we have Y over X. So our X will not be X, it'll be 1. So if we look up here, we see that at the X1, our Y is 1. Oops, I'm sorry, you couldn't see that. Our 1 on the X-axis goes up to 1.5. Therefore, our unit rate is 1.5. This graph goes up at a constant rate of 1.5. So we would write that here as an ordered pair. Our 1 is always our X, and our Y is wherever that X hits on that Y. So in this case, it'd be 1.5. If we have questions about that and want to talk that through a little bit more, you're welcome to reach out. So 1 is always our denominator. When we're graphing proportional relationships, X is always the denominator. So 1 will be in the denominator, 1 will be our X, and then wherever we see that 1 on the graph, the Y coordinate goes in our ordered pair. Now this is an ordered pair, so you do need to make sure that it is in parentheses. All right, last little piece here. Now we write that equation. So this goes also back to when we were actually graphing. And we know that Y equals, again, our unit rate, our constant of proportionality, whatever that is, times X. So our graph moves up by multiplying whatever X value you have. So you could multiply 7 by that 1.5 number to figure out where to plot your next point. Okay, let's take a look at the next piece. So this is an overview. Let's try another example together. So we've got a new graph here. It says, pick a point from the graph other than 0, 0 and interpret this point. So this is what a typical problem will look like. The first one that we did was more expanded out. This is where we will specifically be looking. Okay, so it says pick a point from the graph other than 0, 0. So you can pick any point. I'm going to pick this one right here and interpret it. So I'm going to write my ordered pair for that, which is 3, 12. But you could pick any point listed here. Now, I'm going to then turn this into a sentence. For every 3 hours, X is 3, 12 songs are played. Okay, so I took this point and I'm telling you what that point means from the graph. Now I need to determine the unit rate or constant of proportionality. For here, I always look at the X1, where 1 is, and I circle that point, and that's what goes here. Now remember, this is an ordered pair. So 1 is always going to be my X, and wherever this point hits on the Y-axis, that's my constant of proportionality. So here it hits at our 4, so that's our ordered pair. I then take that and turn that into my equation. Y will equal 4 times whatever X is. So again, for example, if I want to use that 3 as my X, 4 times 3 gets me 12. I can then see values that aren't on the table. I could say, okay, what about 8? I could plug in an X value of 8. 4 times 8, that would mean that 32 songs are played in 8 hours. All right, we've got one for you to try on your own here. It says pick a point from the graph other than 0, 0, interpret this point. Could you go ahead and do that for me, please? So there's lots of points here, whichever you chose, as long as you included the hours and the costs and that it is a point on your graph. Go ahead and now determine your unit rate or constant of proportionality. This one's a little trickier because one's not actually labeled, but we do know that's where 1 is. We see that. And then we also see that that hits halfway between 0 and 100. So your constant of proportionality would be 150. And lastly, I would like you to write me the equation for this graph.